Hello and welcome to Tribe Topper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos. This video session, you are going to understand about a diffraction grating. So what is actually a diffraction grating? As you can see here, there are a number of slits in a slab, you can say a glass slab. So when a diffraction grating happens, what is it? It's a consequence of the effect on the interference pattern when the number of slits is increased. We have already learned this in our previous videos, that how the intensity and the pattern changes when the number of slits goes on increasing. So actually a diffraction grating is just a there to see that how if you increase the number of slits to too many, like typically there are around 600 lines per millimeter, so there are 600 slits per millimeter. So when a white light source would make the light pass through it, what type of pattern you would get, that is very different for a diffraction grating. So generally they're used to produce an optical spectra. So a diffraction grating can rather produce a spectrum. Like if you pass the white light through a diffraction grating, you actually get a band of 7 colors. So you produce that optical spectra with the help of a diffraction grating. When light is incident on this grating, it actually produces an interference maxima, of course, because the light from coming out of each slit would interfere. And that interference maxima at the angles theta, which are given by the relation n lambda is equal to d sine theta. So this is an important relation based on which you would have the questions, and you can directly apply this formula where n stands for the number of slits and lambda is the wavelength of the light used. D is the distance between the slits and sine theta. Theta is the angle for interference maxima. So let's have a look at this question based on diffraction grating. So there is a diffraction grating having 600 lines per millimeter. It is illuminated with a parallel beam of monochromatic light, which is normal to the grating. So this produces a second order maximum, which is observed at 42.5 degrees to the straight through direction. Calculate the wavelength of the light. So now capital N, the number of lines per millimeter is 6 into 10 to the power 5 lines. So, these are 600 lines per millimeter. So, we would say there are 6 into 10 raised to the power 5 lines per meter. So, that would give us what is the distance between two slits? That would be 1 by n. You would divide that by n, right? So, you get 1 upon 6 into 10 to the power 5, which gives us approximately a distance of 1.67 into 10 to the power negative 6 meters. I hope you understand this expression because we have just used the simple unitary method. So there are 6 into 10 raised to the power 5 lines in 1 meter. So what is the distance between two lines? You will say 1 divided by 6 into 10 raised to the power 5. And this is the distance between two slits. Now using the relation n lambda is equal to d sine theta, where this small n represents the order of maximum, and we are talking of a second order maximum. So that means our n is equal to 2 times lambda we have to calculate is equal to d sine theta. D is 1.67 into 10 to the power negative 6 times sine of the angle is 42.5 degrees. So plugging in all the values, you get lambda is equal to this whole thing divided by 2, and you get an answer of 5.64 into 10 to the power minus 7, or you can say 564 nanometers. That is the wavelength of that light which is passing through the diffraction grating. So that's all in this video session. In the next, you are going to learn about the thin film interference. Thank you.